Hey kiddos, we're going to take a look at a strategy to do long division without using a formula or something like that. We're going to use a strategy that we've used for division and multiplication before, but change it a little bit so it works for larger numbers. All right, so kiddos, let's take a look at a simple starter problem that I think everyone would know right off the bat without using a strategy, but this will get us started. If I'm doing division, I'm going to do a problem like 9 divided by 3 equals something. And the first thing I want everyone to remember and recognize is that when I do these problems, I like to use vocabulary that explains what I'm doing. So instead of saying 9 divided by 3, I like to use the phrase breaks down or break down into, because that is exactly what's happening. Division is all about taking large things and breaking them down into smaller parts and pieces, right? So that's what I'm going to look at these problems as. Let's go ahead and try 9 divided by 3 equals something, and I'm going to use a familiar strategy that you've all seen before. It's called equal groups. In equal groups, you take your larger number and you break it down into a smaller number of groups. So I'm going to take 9 and break it down into 3 equal groups. I start by drawing 3 equal groups. I tend to use circles because they're pretty easy to manage and draw. And then I'm going to take my 9 and break it down into each of those groups. So I'd start off with 1, 2, 3, making sure to always share evenly and equally. 4, 5, 6, 7, 8, 9. And then the answer would be, in this case, how many is in one of these groups? And the answer is 3. All right. Equal groups is a strategy we use a lot with multiplication and we use a lot with division, but we have yet to use this strategy with larger numbers. So I'm going to start to show you what happens when we use this with larger numbers, and we'll see what we think about it and how it translates. What I do like about it a lot is that it focuses on place value, right? And it helps us get where we're going. So let's take, in this case, let's take another larger number and break it down into smaller parts. If I had the number, let's say 48, and I'm going to break it down into 6 equal groups. Some of you already know what the answer is because you know your math facts. That is great. Those are going to be handy coming along. But let's say I didn't know what the answer was. I would start by drawing my groups. 1, 2, 3, 4, 5, 6. Oh, gotta squeeze that last one in there. And then I take my 48 and I split it up equally amongst all the groups. I always tell my kids in my class that in division, it is so important that everyone gets something equally. It's a lot like when you're working with little kids, right? You've all been doing things with little kids. Maybe you have little siblings or little cousins, or you've seen little kids at school before. It's really important that everyone gets the same things, or else someone's going to get upset, right? If someone doesn't get exactly the same amount as somebody else, you're going to hear about it. And it's the same thing with division. Everyone gets the same amount because that's what makes it fair. So let's go ahead and split this up here. I'm going to go and split this up into groups of 6. 1, 2, 3, 4, 5, 6. 37, 38, 39, 40, 41, 42. 43, 44, 45, 46, 47, 48. Whew, man, all right, I'm done. I go in there, I count my dots, and I find that there's 8 dots in each one of these circles. But you ask yourself here, what's the problem, right? What is the problem with using this method? The problem with using this method is it does take a really, really long time. But the great thing about it is that it makes perfect sense. You take a big group and you break it down equally among all the groups. So when we do this with the next problem, I'm going to remind you that your math facts is what makes this really simple. So I'm going to increase our number yet again to a larger number. And this is where we're really going to start to see that long division come into play. All right. Before we were just using numbers that are just our math facts. And you don't really need these strategies for your math facts anymore because you should know them. You should start memorizing them. But once we have bigger numbers that we can't just do inside of our head, we have to have something to do with them. So let's take a big number, like a real big number. Like let's take the number 369. That's quite a large number. When you first look at it, you might think, oh my gosh, this number is so big, I'm kind of overwhelmed. Well, don't be overwhelmed. We're just going to take it one step at a time. And this strategy is also going to focus on place value. I'm going to take this really big number and I'm going to break it down into, see, I'm using that vocabulary again, 3 groups. All right. Now, there is a little quick trick or a key to this. We're going to look at a tool that you may have used at school before, and these are place value blocks. If you remember, there are these tiny little cubes that we used for ones. There we go. There are these rods we use for tens and these big blocks that we use for hundreds. And these were really great because you could build numbers with them. Well, we're going to kind of use the same thing, the same idea to break our numbers down. And we're going to use symbols. So I'm going to start off with a square, and that is going to equal my hundreds. Again, it's a symbol I'm going to use to help me out. I'm going to have a line that I use for the tens. It looks just like that rod we have over there. And I'm going to use a dot or a circle, and that's my ones. All right, so going back to our large problem, you start by saying how many groups we need. We need 3. 1, 2, 3. We're going to take this big number and break it down into 3 equal groups. When you are doing division, you always start in the largest place value and you work your way down. The opposite of multiplication. In multiplication, you start with your smallest place value and you work your way up, which makes sense because we remember that multiplication and division are opposites, right? They're inverse operations. So that's something that we're going to get started with. I'm going to start with my hundreds. I have 3 hundreds and 3 groups. The idea is everyone gets the equal amount. Everyone shares the same thing. So I'm going to go ahead and do 100, 200, and 300 split up between the groups. Notice I use that box to represent the hundreds, right? Just like my place value blocks. I'm done with it, so I cross it out. Next up is my tens. I'm going to take my 6 and break it equally into each of these different values. 1, 2, 3, 4, 5, 6. I used up all of my tens. I cross it out. Everything worked out nice and evenly. Last but not least, we do the ones. There are 9 ones. I'm going to use dots for the ones. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's it. You're done with your number. You took a really big number and you broke it down into smaller parts, and you can see all the parts right in front of you. It's very visual. It's very easy to understand. Now, what is the final answer? That's kind of the good question that comes up next. And this is where some kids might get a little confused, but it's really not that bad, especially if we look at this problem like it was a real life problem. Imagine you had 369 puppies, right? Everybody would love that. Man, 300 puppies, that sounds great, right? And you're taking these puppies and you're breaking them into 3 groups to go to 3 different shelters where they're going to get adopted. That's something you can picture in your mind. All these puppies in one place. They can't stay there. They have to get broken up into smaller groups. Well, that's exactly what you just did. You broke all of your puppies up into smaller groups. And the question at the end of that problem is, how many puppies go to each group? Well, if you look at one of these, one of the shelters, all the shelters get the same puppies. That's what they're looking for in the answer. My answer is going to be, put those numbers back together. I have 100. I have 2 tens and I have 3 ones. Ta-da, 123. That's it. That's all it takes. For the next problem, I'd like you to write down the problem, pause the video, try it yourself, and then compare your answer to mine. Did you do the same steps? Do you have the same final answer? Now that we've done a simple version of this strategy and you've practiced it once on your own. Let's try another one, and this time something weird is going to happen with these numbers. And we're going to stop and think about what is it that's going on and what can we do about it. We're going to try the problem 351 broken down into 3 groups. Now, we're going to do this the same we did before. We're going to start with 3 groups. 1, 2, 3. I start with my largest place value, the hundreds. 1, 2, 3. And then I'm going to move along to my tens. But something odd is going to happen with these tens. You might see it already just looking at these numbers and noticing patterns. I start breaking this up. 1, 2, 3, 4, 5. Well, we have 2 extra 10s here, and they do not break down into my 3 groups equally or evenly. Now remember, they must be equal groups. It does not work if there's extra stuff, because like when we're working with little kids, if someone's got extra, someone else is upset about it, right? If one kid gets more Legos than the other kid, then you're going to have some problems. So we want to make sure to break these up equally. Well, you're left with 2 10s. Now, what I heard a couple of students say earlier today was, hey, can those 2 10s be a leftover or a remainder? We'll talk a little bit about remainders. We'll look at those and what they look like, but unfortunately it cannot. The rule with remainders or leftovers is that they have to be less than the groups that you are creating. So if we do have a remainder or a leftover, then we must have it to be smaller than 3. That's the rule. So instead, I have to do something else with this number. I'm going to take these 2 extra ones that I have, or 2 extra 10s, my apologies, and I am going to do something we've done in subtraction problems. So let's go try a subtraction problem for a moment and remind ourselves things that we can do. If I gave you a simple subtraction problem that looked like this, you would look at this problem and immediately notice that there are not enough value. There's not enough numbers in the ones place. You can't take 9 away from 1. It doesn't work. It's completely impossible. So what you have to do is regroup. Keyword, kids, regroup, regroup, regroup. This is a word you definitely need to go to 4th grade with. So we go over to our tens place. We leave 2 10s behind. We regroup 1 10, and now what we have is 11 minus 9, which actually is possible, something that we can do. Let's go back to our other problem and see if this is something we could probably try to do. I have, in this case, 2 extra 10s, right? When I'm done, 2 extra 10s. I am going to regroup those 2 extra 10s over to the ones place. So now I have 21 ones, which actually, let me go ahead and make that in my new color here. 21 ones. Well, if you're thinking about this, you could totally split 21 ones up between these groups equally, right? Even if you did have some leftovers. But let's just think this through. If you're thinking ahead, if you know your times tables, then you already know that 21 and 3 are related to each other. If you don't know your times tables, we're going to go through this one at a time. So we start with 1, 2, 3. 21. And when you're done with all those numbers, right, we have nothing left. The 21 worked out perfectly between those 3 groups. You're going to have your final answer. You look at the numbers that you have in one of your groups. You've got 100, you've got 110, and we have 7 ones. And your final answer is 117. Isn't that great? You can regroup with your long division. Let's try another problem, and this time I'm going to tell you to do this problem on your own, and we'll see what you come up with afterwards. Okay, let's pause in this problem here for a moment and remember that things have to be equal. They have to be fair. everyone gets the same thing. So in this problem, we came across one of these remainder scenarios. I split up my last group and I had 3 leftovers. I had 3 extras. Those 3 extras are what we call a remainder, and they get written in your answer just like this, R3, remainder 3. That just means that you had 3 pieces of something left over, 3 puppies, 3 buttons, 3 pieces of chocolate, whatever it is you want it to be, that did not break down equally, so you leave them off to the side. All right, let's try another problem. And in this next problem, I'm going to ask you guys to think about, again, the steps that we're taking and what is interesting that's happening in the problem. Okay, this is where I'm going to pause. Immediately, I knew that 8 broke down by 4 in groups of 2. So I didn't even go one by one. I just put 200s in every single one of these groups because I knew the relationship between 8 and 4 right off the bat. I went to my 10s and realized, you know what? 3 10s is not going to do it with 4 groups. So I regrouped immediately. And this is the part where you could stop and go one item at a time and split that 37 into 4 groups. However, I'm really tired of doing this one at a time thing. I'm going to use a new strategy, which actually isn't new. This is something you probably have done before, and use my times tables to help me get where I need to go faster. So I'm going to say, you know what? How close can I get to 37 using my 4 times tables? So I'm just going to write them up here at the top and see what I can come up with. I know that 4 times 4 is 16. That's a good place to start, but that's not very close to 37. So I'm going to jump up a little bit. 4 times, let's do 6, is 24. That's closer to 37, but not close enough. 4 times 8 is 32. Ooh, well, I'm getting in the 30s. I'm getting close, but maybe if I just do one more, I'm going to get closer. 4 times 9 is 36. Oh my gosh, 36 is extremely close to 37, which is the number that I have to break up. So I can absolutely at this point go and put my 9 dots in every one of these 1, 2, 3, 4, 5, 6, 7, 8, 9. Or if, as long as it's not going to confuse you, you just want to write the number 9 in each group, you certainly could do that. It works out just fine as long as you recognize which numbers mean which place values. The place value is extremely important. So I'm going to go ahead and do my 9s in each group, and my final answer is not quite done yet. I got to look back here. I was trying to get to 37. I used 36 and I had one item left over. See that one item left over that did not break down equally? My final answer has to include that extra. So my final answer is going to be 209 with a remainder of 1 left over. Let's do one more problem and make this one a little bit more challenging. Try to solve it using exactly the same strategy and then double check your work with mine. In this final problem, I had to notice that I had a thousands place, and the thousands place could not be broken into equal groups, so I regrouped it into the hundreds. The other interesting thing about this problem is that you have one remainder left over. And remember, we always write that remainder onto our final answer there at the end. I'm really hoping that this strategy is helpful for you in long division. At the end of the day, whatever strategy works best for you is the one that you should choose to use. I really like the strategy of creating equal groups and using those symbols to represent my numbers because I can move them in pieces and see my results at the end. But if you like the formula, if you like the big 7, if you like the area model, whatever it is that makes the most sense to you, you go ahead and use that method. As long as you show your work, then you'll make sure you'll have a happy teacher.